Now let's use the property of logs to condense the logarithmic expressions, essentially going from multiple logs back down to one log. In these problems, we're starting with something on the right side of those log properties and trying to move to the left side. Let's take a look at the first one in number 11, log of 5 plus log of 2. For this problem, remember that if the log has no base, it's really base 10. So we'll put this little reminder in here. This is really log base 10. Adding outside the log means we multiply inside the log. So adding on the outside means we can multiply the arguments together, 5 times 2. Well, 5 times 2 is 10, but what's log base 10 of 10? What power of 10 will give me 10? 1. 1 will give me 10. Looking at this on the calculator, let's take log of 5. So I'll do log of 5 plus log of 2. So I'll put 2 and then my log. My calculator does it a little bit backwards. You can see up here log of 5 plus log of 2. I'm simplifying that first side expression. And if I hit equals, I get 1. Even though we have really crazy irrational numbers for log of 5 and log of 2, which makes sense. 10 to what power gives me 5? It's going to be a fraction. 10 to what power gives me 2? It's going to be another fraction. But if I add those fractions together, I get 1. All because 5 times 2 is 10 and log of 10 is 1. So we can use these log properties to help us solve and simplify as well. Taking a look at number 12, log base 2 of 96 minus log base 2 of 3. Subtraction on the outside means we can divide 96 divided by 3. And I think I know what 96 divided by 3 is, but let's just be safe. 96 divided by 3. We can use our calculator to get that. We get 32. Log base 2 of 32. And now, this is really asking me 2 to what exponent gives me 32? 2 to what exponent gives me 32? 2 to the 5th is 32. So log base 2 of 32 would be 5. Now looking at a log expression, log of 2x plus 5 minus log of x. I need to be able to write this into one log, and I have a subtraction going on between these two logs. So that means inside the log, I'm going to divide. Numerator is the one that comes first, the positive log. The negative log will be the denominator. I can't simplify that out anyways because I don't have any numbers for x. I can't do anything with that plus 5, 2x plus 5. I cannot break that log apart in any way. There are no properties for that. So our simplification will be log of 2x plus 5. Divided by x. Taking a look at the next problem, log of x plus 3 log y. I know I'm going to multiply because of this plus right here in the middle, but I have a problem. I don't get to multiply just yet. I have a 3 out front. I've got to get rid of that 3 before I can do the multiplication rule. Remember, the multiplication says log a plus log b equals log AB. I don't have any coefficients in front of those logs, so I've got to make sure if I use that multiplication rule, I don't have any coefficients in the front. I've got a 3 in the front of that log y. I've got to move it. I've got to get rid of it somehow. So I can by that exponent property. I can take that 3 and I can put it back on y as an exponent. So 3 log y is equivalent to log y cubed. Now I can turn these two logs into 1 with multiplication. I'll leave 15 for you to do. Remember that log base e is really natural log. And one thing also to point out, for every single one of these log properties, the bases must be equivalent. If the bases are not the same in these logs, we cannot use these properties. We have to have the same base for the logs in order to use these properties. So fortunately for us, for most of our situations, we will have this, but just know that in general, the bases have to be the same in order for us to use these properties. I want you to try 15 on your own. 1/2 natural log x plus natural log y. Try that one on your own, see if you can get the answer. I'm going to look at number 16 next. 2 log base b of x plus 3 log base b of y. We've got numbers in the front. Let's first move the numbers onto the exponents of the arguments. So we'll have log base b x squared using that exponent property in reverse, plus log base b y to the third. And now I've got log plus log. I can multiply the arguments together in one log. Log base b x squared y to the third. Looking at the subtractions, I'm going to let 17, you try this one on your own. Again, natural log 5 natural log x minus 2 natural log y. See if you can get that down to one log. We're going to take a look at 18 together. 3 log base e of x. That's natural log 3 natural log x minus 1/3 natural log y. Again, coefficients in the front, let's move them so that they are exponents on the variables. I'm going to keep that subtraction there. So I'll make this y to the 1/3. And then natural log x to the third. Subtraction means I divide x to the third over y to the 1/3. And usually we don't leave the rational exponents like that. We go ahead and change them into the radical form. X to the third over cube root y. And we're going to take the natural log of that. That's condensing our 3 natural log x minus 1/3 natural log y into natural log of x to the third divided by cube root of y. And that'll conclude our practice for now. For solving equations with logs, we're going to be using this technique to take multiple logs in an equation and combine them into one log. So in the next lesson, we'll look at solving equations with exponential expressions and solving equations with logarithmic expressions. We're going to take advantage of the fact that logs and exponents are inverses of each other in order to be able to solve these equations.